Thank you. Great pleasure to be here. Great collection of people. The session we're now going to have is called Mission Possible, Transition to Clean Electrification. And I'm very pleased that that is stealing a title from reports by the Energy and Transitions Commission, which I chair. We've had a series of reports called Mission Possible, that it is absolutely mission possible to get to a net zero economy across the world by 2050. And it's absolutely clear that the single most important way to get there is massive electrification, either directly in the form of electricity or indirectly in the form of hydrogen. We see a world in which direct use of electricity will go from 20% of final energy demand today to over 60% by 2050, with another 10 to 15% of demand being met by hydrogen, and most of that hydrogen being made from electricity in a green electrolysis process. This is a complete revolution. The good news is that the actual generation of electricity can be done in a zero carbon fashion, cheaper, much cheaper than fossil fuels. The cheapest way in most parts of the world, and increasingly this will be more and more the case, to produce a kilowatt hour of electricity is from wind or solar. And in the cheapest parts of the world, the figures are absolutely stunning. We are now seeing auctions in Saudi at 1 cent a kilowatt hour, $10 a megawatt hour for electricity. But we are also seeing thumping reductions in the cost of producing electricity offshore in the North Sea. So actually, we're in a situation where solving the problem of generating electricity, that's easy. We are left with, I think, two main problems. One is what to do when the wind doesn't blow and the sun doesn't shine. Everything to do with balancing supply and demand over the day and over the year. All the issues about storage, demand management, interconnection, and a flexibility of the system. And secondly, how effectively to extend electricity beyond the uses where we can directly use electricity to that extra 10 to 15% which could come from hydrogen. So what we're going to talk about today is that set of issues, not how to generate electricity cheaper. We sort of know how to do that already, but how to balance the system and how to extend it even further. And we have a panel, a great panel of 5 people, and I'm not going to go through introductions each to begin with and take up time for that. I'm just going to introduce them one by one. 4 of them here, and my good friend Thierry Leperc. Hi, Thierry, on the video from somewhere in Europe. Where are you, Thierry?
In hot Paris. That's the hottest place on Earth right now, which is courtesy of climate change. Thank you.
Okay, I will bring Thierry in later, but we're going to begin with, and it's about 3.5 to 4 minutes each, and then we'll have a question and discussion thereafter. I'm going to begin with Javier Cavada, CEO of Highview Power, who have a technology which provides us with the sort of medium-length storage, which could be part of the system. Javier, far away.
Fantastic. Thank you, Adair, and it's such a pleasure to be face-to-face, and I think we can compete with Paris as the hottest place in Earth today in London, and I'm a Spaniard. So, but Highview Power, we have developed a technology in the last 16 years about creating pump hydro capabilities without having the limitations of pump hydro. So how have we done it? I mean, we do just simply taking equipment and technologies that are very well proven in the market for the last 30, 40, 50 years, utilizing compression of air, the air that we are breathing. We compress it, we refrigerate it until it reaches a point of liquefaction. It liquefies, and the key of the technology is that when the air becomes liquefied like liquid hydrogen, liquid nitrogen, liquid oxygen, all the gases in liquid point, it changes the pressure demanded to store it to atmospheric pressure. So it's extremely cheap, extremely low cost to store the air in liquid form. So extremely scalable as a pump hydro, but extremely easy to modularize and deliver very quickly. So we have a very small footprint, no degradation. So in a way, mission possible. So we are having projects in Spain, Canary Islands, Chile, California, and of course Scotland and northern part of England. So those were my 3 minutes. Very excited to be here.
Good. Thank you, Javier. Just for those who don't understand, it's useful to understand that in this storage issue, we have a spectrum of time periods over which to do the storage. We have in India, we have solar by day, the air conditioners are running overnight. How do you store it and release it over 4 hours? And many people see lithium-ion batteries as the answer to that. But then you have, what do you do if we have a whole load of offshore wind in the UK, and if we've electrified our domestic heating, what do you do if the wind goes down just at the time of the peak demand? And how do you store it over several days or even weeks? So this spectrum of storage needs is very important. We might come back, Javier, to ask you later, where do you fit in that spectrum of storage needs? Fantastic. But let me go on immediately now to Simon Morrish, CEO of X-Links, where his solution is to bring us electricity from far away, where it will be windy and sunny, even when it's not windy and sunny here in the UK. Simon.
Thank you, Lord Turner. I'm very excited to be here today and obviously to discuss these really important challenges. I am passionate about the environment and about trying to do what we need to help save this planet. And I believe it's something that's absolutely key for all of us as business leaders to lean in and to focus on this. Interconnectors are a key part of this problem to solve. So as Lord Turner mentioned, we are well on the way in terms of the renewable energy generation from both wind and solar. But we have not solved the intermittency of that. Battery solutions are one part of that, and short-term storage. The other part of that solution is long-distance interconnectors, where you can move electricity from different regions to other regions. 2.5 years ago, I founded X-Links, and we've made incredible progress to take solar and wind from the Sahara through a 3,800-kilometer subsea cable back to the UK to provide long-term, flexible power there. And also, at the end of the day, I'm an economist, okay? And economics really matter. So it's not just about having a really good solution here, it's at what price. We can provide firm base load to the UK at just over half the price of nuclear, okay, in terms of Hinkley's recent auction. So it's an incredibly compelling point. And the thing I would leave you with is the last 3 weeks of April, the maximum capacity factor of wind in the UK was 20%. And our solution would have provided 150% of all the power that currently is being generated by wind during that period. I'm an enormous proponent of wind. It's absolutely the key cornerstone of our route to net zero, but we have to be able to balance that with moving electrons from over long distances.
Right. Simon, thanks very much. So we've heard about a longer storage solution than lithium-ion batteries, the interconnect route forward. And then there's another interesting development happening in electricity systems, which is a much greater role for decentralized generation on rooftop and commercial. And Sarah, former CEO and founder of Ferro Energy, would you like to give us a perspective on how that fits into the picture?
Absolutely. So my business, which I sold a year ago, so it's no longer my business, but is Ferro Energy, which is develops and invests in distributed solar projects in emerging markets, and we ended up focusing almost entirely on Brazil. And what that means is we're looking at rooftop projects and small ground mount projects spread out all across the country and sort of in remote places, providing power to mainly through the grid and directly to corporate off-takers. Now, solar is obviously at a very different point in its technology path from a lot of the other technologies we're talking about. There is very little technology risk, in fact, no technology risk at all left with solar. The cost has come down enormously, and the challenge really is about how to deploy it at scale as fast as possible. In the utility sector, which is the really big solar projects, that has become a completely mainstream investment opportunity. But distributed solar is a little bit behind. And as I started the business in 2014, that was the point at which the cost of distributed generation was just about getting to grid parity. And we've kind of rode the wave since then as the cost has come down and down and down. And the challenge now is all about how do you scale as fast as possible, including in places where it's difficult to invest in emerging markets, where the cost of capital is high. And the real trick is about business model innovation. How do you effectively apportion the risks between the users of the energy, the system, the investors? How do you design how do you design and structure the whole system so that the right people are bearing the right risks, the cost of capital comes down as much as possible, and the cost of the technology comes down, and you get mass deployment as fast as possible? Because we are looking, we need to, the electricity generation globally has to increase by 4 or 5 times what it is right now, and so much of that is in emerging markets and difficult places. So that is utility stuff, which is pretty much sorted, but the distributed generation piece of it is way better than where it was when we started in 2014, but it's still got some way to go. And so it's all about finding the new financing structures, new business models that just minimize the friction, get mainstream capital behind this, and just allow that sector to grow as fast as possible. My hope is that there are a lot of technologies being talked about today which are at a much earlier stage, that they will get to that point soon, and then it won't be about the technology innovation, but it will still be about business model innovation and finance innovation, because we've got to scale everything as fast as possible if we're going to get to net zero.
Sarah, thank you. Very interesting a perspective there on the developing markets. To give you an idea of the scale of what we believe is required in electricity growth, even in rich developed countries like the UK, we will probably by 2050 consume 2.5 times as much electricity as we do at the moment. In India, that will be 6 or 7 times. In Africa, it needs to be 20 times, given the incredibly low level of electricity use there. But we have a major challenge, and I would say the biggest challenge is in Africa, which has unbelievable resources of solar and wind, where but until recently, apart from North Africa, where Simon and others are working, if you look at sub-Saharan Africa, it had less solar 2 years ago than the Netherlands, which last time I visited it wasn't the most sunny part of the world. And this issue of how we develop business models which reduce the cost of capital in particular for developments, whether it be of grid scale electricity, solar and wind in Africa, or of distributed, I think is hugely important alongside the technology innovation. Now, Robert is the head of CleanTech at IP Group, who are in many different technologies. He's also a member of the Energy Transition Commission and has played a major role in the development of our thinking. But from your perspective at IP Group, what should we be thinking about, Robert?
Thank you, Dave. So people often ask me, as a sort of patient capital climate tech investor, sort of what are you looking at? And we have the privilege to have a very long time scale for our investments. So picking up the theme that Adair started with on the dominant role of renewable electricity, the risk that we're kind of investing against at the moment is that we don't deploy enough energy capacity fast enough. So one of the numbers that comes out from the E2C analysis is 100,000 terawatt hours coming from renewables from less than 5,000 today. And a way that you might think about managing that risk as a technology investor, and Simon's already referred to it, is capacity factor. So there's a perception in the industry that solar and wind are both done, and we have a very low-cost technology, which do work very well today, but there's a big risk in deployment rate. We're not getting enough projects through. So every single solar panel that goes in, every kind of wind turbine that's installed, needs to contribute as much energy as possible. So that's innovation in the actual units sort of energy-generating technologies themselves, and also integrating them into the system. So if you have medium-duration storage, like Javier does with Highview, you can actually deliver more energy from the same project because you're not curtailing. So for us as kind of investors with a very long time frame, big areas for us that we're focusing on are how do we help renewables do more. So it's not about gigawatts of renewables, it's about terawatt hours of energy. That's a major theme. There's a second theme which I think is very important, and Andrew's already referred to it, which is the role of nuclear and new nuclear. So things like small modular reactors, and in our case, we've also invested in fusion. Now, it's very difficult to say how long fusion is going to take or whether it will even work. But if you look at the risk that we don't deliver enough clean electricity, having option plays like fusion is worth doing. And as a side effect of the incredibly difficult problem solving that you have to go through to commercialize something like fusion, you generate a bunch of other value. So the key message is we need to deliver huge amounts of renewable, of zero carbon electricity. And in a sense, we're not done in terms of innovation. As investors, there's a huge opportunity to continue to sort of plow capital against those themes. Thanks, Adair.
Great. Thank you, Robert. Now let's turn to hydrogen. It's absolutely clear that in addition to direct use of electricity, hydrogen is going to be hugely important. At the Energy Transition Commission, our base case scenario is that the use of hydrogen could go from 100 million tonnes today to, say, 600 million tonnes by 2050. Uses of hydrogen could include producing all of our steel from direct reduction, using hydrogen as the reduction agent rather than coking coal. That is absolutely possible. May well be the case that long-distance ships in the future burn ammonia in their ship engines. If you go and talk to companies like Maersk, biggest container shipping company in the world, that is the front runner that they are looking at the moment. But hydrogen could also be part of this balancing the electricity system, because we could make hydrogen when we have surplus electricity and then burn it back through gas turbines when we need it, when the sun isn't shining and the wind isn't blowing. And Thierry, who I've known for several years now, is working on major projects to develop really massive scale hydrogen developments, green hydrogen developments, electrolysis across Europe. Thierry, can you give us your perspective?
Yeah, thank you, Adair. The time of hydrogen has come. It's come now. It's going to be mass scale very, very soon. Just a few words about my own background. I'm a serial entrepreneur, started several companies, including SolarEdrect, which built 3 gigawatts of solar across the planet, 4 continents, including 1 gigawatt in India. I was a pioneer of competitive solar. We reached $20 per megawatt hour in projects in Mexico a few years back. Company was sold to NG, and I was for 3 years when we met with you, Adair. I was at the executive committee of NG in charge of technology innovation. Now, over the last 3 years, I've started a new company and worked on hydrogen. So what are we talking about? Well, I'll tell you from a very concrete standpoint where we stand today. We have launched, my company has launched a consortium, not just in itself, but a consortium of 40 companies called HyDeal, which was made public a few months back, which is the largest consortium, green hydrogen consortium in the planet. It's a European consortium starting from Spain, where you have the solar and hydrogen, potential hydrogen resource in plentiful and quantities. And it has set its objective with a very simple goal, 1.5 euro per kilogram delivered now, which is the equivalent of fossil fuel costs in Europe. And what we are doing right now is we've brought these 40 companies together, which include solar developers, electrolyzer OEMs, engineering firms, gas TSOs, because the midstream of that is fundamental. You've probably heard about the European Hydrogen Backbone. We have most gas TSOs, the largest, at least part of our grouping, and we have some of the biggest off-takers in chemicals, in steel, and in energy, and in steel production. Now, I'd like to just focus on 2 examples of that. Then again, the objective of HyDeal is 3.6 million tons of hydrogen delivered in 2030. That will need 95 gigawatts of solar and 67 gigawatts of electrolyzers. I can see it's quite ambitious. It's not just a goal. It's now 2 projects. I'll very briefly mention 2 projects which are now being developed, officially developed. One is a 4 million ton steel plant in northern Spain, which will be converted to DRI, expected completion 2025, to produce the first mass-scale green hydrogen green steel production in the world, based on about 7 gigawatts of solar and 5 gigawatts of electrolyzers in the northern part of Spain. Another project which is, and then again can elaborate if there are questions about it. It's a CCGT, an 800 megawatt CCGT, which will be based there again in southwestern France, very close to the Spanish border, using that very abundant, cheap green hydrogen that we can source from Spain with its very high irradiation. And we are going to do the holy grail of power, which is 24/7, fully dispatchable, fully renewable power, which is what is matters. You know, variable power is worthless, pure and simple. What is essential is power supply that guarantees 24/7 supply, just the way we're doing it today with coal, nuclear, and gas. And this is what we need to replace. This project is built with EPH, a very large coal and gas-fired generation company. This is the way to go. So obviously, yes, hydrogen is ready now to go at scale in a competitive manner, and Europe is showing the way from that standpoint.
Great. Thierry, thank you very much. Well, that's given an idea of some of the different technologies and business models which are being brought to bear to deal with this intermittency problem. I'd like to continue the discussion maybe by moving on to the issue of asking the panel, what do you need from government and finance, right? We've got an idea of what the technologies are. It's technologically possible, but is the finance there? Do financiers have the right attitude? Are they seeing the possibilities here? And can this happen in an entirely free market approach, or how much subsidy and support is needed from government to get us going over the first stages? And I'm going to ask Robert, I'm going to give to you first to give a perspective on that, and then go round to other people as well. Yeah, Robert.
Thanks, Adair. So with respect to investment flowing into basically firming renewables, delivering baseload power, as Thierry referred to, we're a listed company. We're a bunch of asset managers and family offices who hold shares in our company. And I get the question, what do I buy? I do infrastructure investing. What do I buy now? And storage is now coming into focus. So we're seeing listed storage project development companies coming through in London. That is helpful. But because a lot of this stuff relies on the grid, really moving energy around, delivering it to end users, the whole system needs to be integrated. So there's an inevitable role for the transmission operator in the UK national grid and the regulator setting the market conditions so that those projects, storage projects, be they medium duration, short duration lithium ion, can get deployed and get access to the grid as quickly as possible. And that's one of the key risks. So I talk to people around, do I back these storage projects? They can look at the cost down of lithium ion batteries. That's easy. What they find hard to price is, am I going to wait for a connection? Is the market reform that government say is going to happen in time? So that would be the message to policymakers is there's a huge amount of capital here. We need to think systematically, and we really need regulators, government, and industry to work very, very closely together.
Simon, let me turn to you. I mean, if you get your project, you've got to interconnect it to the UK grid, so you've got to have a relationship with National Grid. You've got to get the finance as well, and you've got to do a deal with somebody. What has to happen to make your project happen?
So really, the single biggest thing that we need in terms of our project is a framework from the government to be able to give certain certainty on this. So really, to your point there, I mean, what the government has done incredibly well over the last sort of 12 months with the COVID vaccine was actually spread lots of different options and was in a place where many of those seeded, and what I think we led the world in that respect. What I believe the government needs to do now is actually do similar things where it is seeding lots of different options. Nobody really knows exactly what are the right ones, and there will clearly be debate within this panel. I'm absolutely convinced that what we're doing at Xlinks is the right option, but there will be other people who I'm very, very happy to debate on whether it's not. And so what we need is a CFD or something equivalent from the government.
Contract for difference.
Yeah, sorry. And what that is it's a firm price for the next 20, 25 years at an unsubsidized rate. So we're not looking for any subsidy. And so going on your point about finance, we don't believe we've got any issue with finance. So we think we can, the finance will all be in place. We just need that support and from the government, and in a way that they're sprinkling help and very, very low cost on a bunch of different technologies to help win this race. And I think that would be very, very powerful, and it will help us as business leaders really accelerate that process.
I'm going to come back to Thierry, you now. Thierry, you talked earlier about your price target is $1.5 per kilogram. A kilogram of hydrogen produces 33 or 38 kilowatt hours out of it at something called the lower and higher heating value, which Thierry and Robert understand and I don't. But call it 35 kilowatt hours, 1.5 kilograms. Two key things to the economics of that: the cost of renewables and the cost of the electrolyzers. Cost of electrolyzers will come down. Do you need support from government to do that? Is that about the infrastructure? Is it about subsidy? Is the finance there to do it? Or is there nothing that's going to stop you doing it, Thierry?
Thank you, Adair, you know me. If we were to ask at Ideal, if we were to ask for the very bare minimum that most people are asking, which is €1 per kilogram of subsidies, we would ask for 72 billion euros, 72 billion euros of subsidies for our business. So the volumes that we're talking about make it totally impossible to have any form of subsidy. I'll give you an example. The US grew by 1 Saudi Arabia in oil in the last 12 years. Nobody in the Permian Basin went to Washington. They went to Wall Street. And that's where they got $1 trillion to make that shale revolution happen. So the same is going to happen for hydrogen. Hydrogen not as a climate policy-making object, but hydrogen as a commodity. And a commodity comes with a market where you have people who are ready to pay a certain price. And then it comes with the capacity to deliver that. And you're right, we need very, very cheap power. The threshold is 15 euros per megawatt hour. Including power transmission, by the way, 15. If you are above 15 euros, you're out of business. You will never do business, which means that the only way is solar in Spain and Portugal when it comes to Europe. France, too bad. Germany, too bad. Wind, too bad. Doesn't work. You need that very, very cheap. And then you need to scale up these electrolyzer gigafactories. We've seen announcements in the last couple of weeks. The UK has ITM, which is a great company. And there are others which made announcements. To be very frank, we're discussing with Chinese people. I think the war is over because China is already moving to gigafactories of electrolyzers. This will be announced quite soon. And we'll see that what has happened in the shale gas industry is going to happen with a vengeance with hydrogen. And some of the value chain players are actually in Europe, in Asia, more than the US, by the way.
Great, thank you. This issue of bringing down the cost of electrolyzers, absolutely crucial. Electrolyzers now have been being bought at $850,000 a kilowatt. Thierry will want to be buying them at $200 a kilowatt. And there are signs of it heading absolutely in that direction. We are seeing the possibility of electrolyzer costs coming down in the similar sort of collapse that we've seen in batteries over the last 10 years. I'm going to come to you next, Javier. Can you just talk a little bit about the economics of your projects in specific locations and others? Because you were mentioning to me earlier that the easy first adoption of your projects is in islands, where you get rid of diesel gensets, etc. But if you then take it to the UK, will you need a CFD like Simon? I mean, how does that work?
I mean, fantastic. I mean, definitely the island grids, and I want to say Canary Islands, Chilean mines, which are in a way islands also, very vertically integrated utilities in the California area that they cannot cope with fossil fuels. So it's also, I mean, at the end, you get rid of the need of a government to regulate, because at the end, you have almost a monopolistic utility that, well, they can only, in an island, I can name it Tenerife, they are bringing diesel liquid fuel by helicopter with pretty commonly. I mean, and you know where it is located. It's really far from the peninsula in Spain. So there is an absolute move to decarbonization. There is trillions of pounds being invested in wind, in solar, and I'm listening to the technologies, to the projects. I mean, the market, the grid is requiring all these technologies at massive scale, at massive speed. And if we look at the UK and our technology, I mean, Adair, you were asking about the the duration of our technology. I mean, our technologies, I'm a mechanical engineer, so apologies for that. We can do from 1 minute, but doesn't make any financial sense. We start in 6 hours.
6 hours.
But we can do 20 hours way better. We can do 100 hours. But all our projects are from 6 hours to 16 hours today. And the reason is that the governments cannot pay for more than 16 hours because they have enough backup, enough grid services, etc. But again, we are compressing air, releasing it later, turning a turbine, an air turbine, and a generator, so providing all these inertial system services that coal, nuclear, gas, diesel provide, that hydrogen will provide in the combined cycle. So we need to partner with inverter-based technologies, because at the end in the UK the grid is totally analogic, so you need to provide balance to the grid. You cannot just multiply by 10 the size of the grid, so all the wind is coming from Scotland. Everybody knows about the Pathfinder program that is happening here. So UK, very much looking at the vaccination program, is leading in the sense that UK is the first country that pays the services for inertia, synchronous reactive power, voltage support. All the other countries, and I can name mainland Europe or US, they want these services, but nobody pays for them. So that's in a way the need of the governments, of the policymakers, to set rules that enable storage at larger scale to happen now.
And Sarah, let's turn to distributed again, and in particular in the developing world. So let's look at Africa. You look at it, you think there just ought to be an enormous opportunity to do distributed solar in particular in Africa, but it's going very slowly. What needs to happen to make it faster? Is this development banks? Is it blended finance? Should this be part of, the G7 just agreed 100 billion of climate finance? Is this where it should be going? What's your perspective?
Yeah, so it's really tricky, and the reality of trying to get solar projects in the difficult markets off the ground is difficult, and there are a lot of reasons for that. But the main thing is around risk and how the potential investors view risk in those projects. And a big part of that in emerging markets is to do with the energy systems and the grid and the policy. You need to have a well thought through and well designed set of policies in each country that you're working in order to justify the investment. So Brazil. So we looked at investing in a number of different countries, mainly in Latin America and not in Africa, but it's very similar. And Brazil was the one place where the kind of all the different policy things lined up, such that suddenly we could get the risks came down sufficiently that we could give our investors clarity around the long-term revenues that we were going to be able to generate and the long-term investor returns. Unless you have that right set of policies and they've been thought through well and it kind of integrates with the whole energy market and there's not kind of uncertainty knocking around, it's just not investable. The other thing that's a real challenge in those sort of markets is currency risk. So obviously there's a lot of capital around looking to get into to invest in solar and wind, but they want US dollar or euro returns, and that is just not viable in a system where the electricity market is in local currency. And so there are real challenges there. And there is some innovation there happening with development banks to try and bridge that, but frankly, I don't think anyone's really done that particularly well. So you have to find investors who are willing to take currency risk as well as energy market risk and policy risk. And most countries, my understanding is in Africa, have not yet nailed that right combination of policy mechanisms in order to de-risk investment. And so finding ways to support the policy framework to make those markets investable is the biggest thing, because if the policy framework is right, the investment will flow. That's the key.
We've got another 8 minutes left, and I'm going to try and have a quick round, and I suspect there are different topics that different speakers could talk to, so I'm going to suggest two, and they can choose which one to go from. One is, how important is demand management in this? right? So we have these intermittent sources of supply, and we've been talking about linking, Simon's plants down in Morocco, linked into the same system as the North Sea. But the alternative is to make sure that we're all sensible about when we charge our electric cars, when we switch on our dishwashers. There may be industrial processes. So I'd be interested in, is there a perspective on how much could we rely on demand management? Or is that a bit of a sort of chimera which people have, that we'll just all get cleverer about that? And the other thing I'd be interested in sheer technology terms, where are the extra steps of technology? In a sense, you're saying you've got the engineering fixed already. There isn't a new technology that has to occur, but are there across the different areas, bits at the frontier of technology that could take it to the next stage? I'm going to start with Thierry. Thierry, on either of those, you've been in this area for a long time. Do you think the demand management is a big opportunity, or ultimately, are you going to have your renewable energy making hydrogen into a CCGT? Consumers are going to continue to be stupid and just use electricity whenever they feel like it, but you'll have your CCGTs ready to switch on.
I'm only in favor of stupidity. You don't want consumers hate constraints. Consumers hate to be prohibited to do what they want when they want to do it. Consumers hate to pay a lot of money for something which is just what they've been used to. I mean, if you're saying that energy security is something which is going to be a scarce commodity in the future, you're not bringing an added service to the customer. You're taking something away from them. And what consumers want, and that includes industrial consumers, and they want to have totally reliable power. That's the first, the so-called energy trilemma is energy security. Anytime, anywhere, and then it's affordability, and then it's zero carbon. Now, if you're saying you're going to have zero carbon at the expense of energy security or convenience, or at the expense of energy affordability, you're giving a lousy deal to consumers, and they will not take it. If you can come and say, you can keep your very bad habits of flying, of using power whenever you want, and Africa, you know what? You can multiply your consumption by 20 times and everything will be okay. I'm talking about energy abundance. I know this is something that people will be horrified, because abundance is a word that people are fundamentally against, certainly in France and other countries. But this is where we're headed, energy abundance.
So the answer there is demand management is interesting, but we have other solutions. Of course, other people have different points of view. And they point out that if there are 2 billion electric cars on the road in 2050, and they each have a 60 kilowatt hour battery, that'll be 120 terawatt hours of storage sitting around in any case, which even if we're consuming 100,000 terawatt hours a year there, will be 8 hours of storage sitting around already paid for. Robert, do you think we're going to tap into that effectively, or is Thierry right that ultimately we'll just have dispatchable sufficiently cheap that people continue to treat, electricity as they do at the moment as being the same throughout the day?
So I think our view on demand is, if you look at the UK as a microcosm for the global system, we've done a lot of progress, and Andrew referred to it earlier, in terms of decarbonising energy generation. The big challenge for this country is decarbonising heating, and to some extent transport. And the solution is electricity. That looks fine. The grid that we have, which is sort of getting on for a century old, can't cope with everyone deciding to plug in their EV and turn on their heat pump at 6 p.m. every evening in 30 million households. It will fall over. And the cost of reinforcing it to deal with that huge power change is prohibitive. So you're going to need a form of demand management, and that's starting to happen. The UK, as Javier said, is actually a pretty good marketplace for these things. So you've got companies like Octopus, a highly innovative utility in the UK, offering sort of EV charging, and you can get negative prices if you do your things correctly. So we should do that. There are innovators making that happen, founders making companies, and it's something for the policymakers to entirely encourage. And the issue is that as we move away from fossil fuels, so natural gas in particular, where you can just deliver 150 gigawatts of additional power in a couple of seconds through the gas network, We just can't do that with electrons. So we need to think a bit more holistically about that demand side. And it's not just the UK. If you look at countries like India with the air conditioning load, as climate change gets worse, as you get more sort of lethal heat days, you need to think about how we improve building fabric, improve cooling technologies so that that demand piece, along with more renewable energy in India, is manageable.
Javier, should we be moving to much more flexible pricing of electricity during the day? That would support your business model, but do we need to head there on the demand side as well?
Absolutely, absolutely. And I will be super eager to get a glass of wine with Thierry in the near future when we get out of this crisis of COVID. But in the last 15 months, we have been in at least the biggest crisis in terms of behavioral management for the society in my generation. I'm sure that we are moving into the biggest crisis with climate change for the coming generations. So that's not manageable without price management, demand management, educational management. So we really need to be, if we want to be stupid and all charge at the same time, we will need to pay a lot more and be able to subsidize those who are clever and don't need to pay more. That, of course, enable more storage, enable more interconnector, enable more wind and solar, more decarbonized grid. But there is no way that we don't learn the lesson. And probably we need to fall several times, but we're going to learn the lesson hardly again.
Sarah, this issue of either demand management or technology, but when you have distributed stuff, of course, the demand management and the supply is right down at the distributed level. But what's your perspective on this?
Yes, I mean, I don't think that it is reasonable to expect consumers, as you say, to adjust their behaviour in a way that makes their kind of quality of life worse. But there are so many opportunities for demand management technologies that really make no difference whatsoever to the consumer's reality and are, frankly, going to be way cheaper than storage and other things. And I think not taking advantage of those opportunities would be just a huge missed opportunity. And frankly, I don't think that you'll be able to get to net zero without them. And there are so many technologies kind of coming through that can solve little pieces of that problem. It's not kind of one big thing that's going to answer that. There's lots and lots of things. The EV1 is one really good example. I think you have to find all the opportunities you can to manage demand in a way where the user doesn't really notice, but it has a really positive impact on the grid. Because if you can do that and you need to invest in way less generation and fewer batteries, that the total system cost of getting to net zero will decrease. So I think you have to do it.
Simon, you've got the last word.
Oh, really? Like Andrew earlier, then. Okay.
Nope.
Yeah. So for me, I completely agree with you, Sarah, on that. I mean, it is demand management is part of the solution. It's not going to be the whole solution, but it's needed. I also agree, Thierry, that people don't want to change behaviour. Octopus has done a fabulous job in terms of bringing new innovative things to market, and people are embracing that. But not everybody is going to embrace these kind of things, and so we have to be able to help that pricing to be able to sort of get this to get the balancing right.
We're out of time. Thank you very much to the panel. I think we've had a good run through some of the technologies and issues related to this fundamental challenge of we know how to get cheap renewable electricity. All of our problems are what to do when the wind doesn't blow and the sun doesn't shine. And I think we now know that there are a lot of solutions to that problem. Thanks very much.